Picture a silent, icy wanderer hurtling through the void, a relic from beyond our solar system, now on a collision course with destiny. Its name is 3I/Atlas, an interstellar comet that has astronomers from Harvard to NASA on edge. Once thought to be a harmless passerby, this cosmic wildcard is now tracking dangerously close to Mars, close enough to graze within the distance of Earth's moon from the red planet. The stakes are astronomical. A potential impact could unleash chaos, reshape Martian landscapes, and threaten humanity's dreams of exploring our neighboring world. As of September 17th, 2025, the latest data paints a chilling picture, with the margin of error shrinking to a razor's edge. What if this comet isn't just a fleeting visitor, but a harbinger of a planetary catastrophe? Buckle up as we dive into a gripping tale of science, suspense, and the race to protect Mars from an interstellar missile. Let's explore the urgent questions. How real is this threat? What's driving the warnings? And could Mars, our cosmic neighbor, become ground zero in a solar system spectacle? Share your thoughts in the comments below and subscribe to stay locked into this unfolding drama. It began in the quiet hours of a chilly Cambridge night. At 2:13 a.m. inside Harvard's Center for Astrophysics, a high-performance computer cluster hummed to life, churning through orbital calculations for 3I/Atlas. The numbers flickered across the screen, and something was wrong. The comet's trajectory had shifted, closer, tighter, slicing within 400,000 kilometers of Mars compared to the previous week's data. For context, that's less than the distance between New York and Los Angeles, a cosmic stone's throw for a planet. The margin of error, once vast enough to dismiss concerns, had collapsed dramatically, now smaller than the orbit of Phobos, Mars's innermost moon. Panic didn't erupt, but tension did. Encrypted emails zipped between offices, and Slack channels buzzed with urgency. Graduate students, bleary-eyed but laser-focused, ran Monte Carlo simulations, feeding in fresh data from the James Webb Space Telescope, JWST, and the Very Large Telescope, VLT. Each observation nudged the comet's path a fraction closer to Mars. By mid-morning, a draft press release circulated with a subject line that sent chills through the department. Potential Mars intersection, urgent review. Across campus, experts from the Black Hole Initiative and the Minor Planet Center joined the fray. One postdoctoral researcher, staring at a covariance matrix, a mathematical map of possible futures, typed a stark message in a group chat. This isn't a drill. The orbital uncertainty ellipse, the astronomers' shorthand for where 3I/Atlas might end up, had narrowed to a sliver. Internal risk models, updated just 2 days before the public alert, showed the probability of a Mars encounter rising tenfold. The odds were still low, but the shift was enough to raise red flags. Behind closed doors, the mood was electric with focus. Every data point was logged, time-stamped, and triple-checked. Harvard's computational models, now running hourly, revealed a persistent trend. Unless a major outgassing event, a sudden release of gas from the comet, pushed 3I/Atlas off course, it would pass dangerously close to Mars. Close enough that a single unpredictable pulse could tip the scales toward catastrophe. The decision to go public wasn't made lightly, with NASA's Jet Propulsion Laboratory, JPL, already requesting Harvard's latest orbital solutions. Silence was no longer an option. The world's attention was about to shift from academic caution to planetary defense. What do you think? Could this be the wake-up call humanity needs to take cosmic threats seriously? Drop your thoughts below. In Pasadena, California, the handoff from Harvard lit a fire under NASA's Jet Propulsion Laboratory. JPL's trajectory analysts, veterans of tracking near-Earth asteroids, pivoted to 3I/Atlas with laser precision. Fresh data from the Hubble Space Telescope and ground-based arrays forced a grim revision. The comet's closest approach to Mars had shrunk to 1.95 million kilometers as of September 14th, 2025. Less than 6 times the distance between Earth and the Moon. That number alone didn't sound alarming, but the comet's speed and trajectory did. Barreling in at 87 kilometers per second on a retrograde high-inclination path, 3I/Atlas was no ordinary visitor. A glancing blow at that velocity would unleash energy unseen in human history, a cosmic explosion that could scar Mars forever. In JPL's control room, Dr. L.C. Jones, the lead analyst, raised an internal monitoring flag. The comet had entered NASA's heightened scrutiny zone, a category reserved for threats that could jeopardize active missions or trigger international protocols. The Mars Reconnaissance Orbiter was tasked with high-cadence imaging of the comet's inbound path. while the Deep Space Network's Goldstone antennas aim to resolve the comet's nucleus and refine its velocity vector. Liaisons from the Planetary Defense Coordination Office, PDCO, joined nightly briefings, their presence a reminder that this was no academic exercise. NASA's public statement was measured, but the internal consensus was stark. The risk, however remote, now carried the weight of global attention. Every new data point trimmed the uncertainty ellipse, and JPL's Monte Carlo models nudged the probability curve closer to the PDCO's critical threshold. The simulations painted a fan of possible futures, with the best fit path threading safely through space. But the outliers, those faint pale lines at the edges of the fan, brushed within 50,000 kilometers of Mars, closer than its outer moon, Deimos. For orbital dynamicists, that sliver of risk was a chasm. The question loomed over every monitor. What if the next data point puts Mars in the bullseye? How would you feel watching a planet we've explored for decades face a cosmic threat? Share your take in the comments. At the heart of 3I/Atlas lies a mystery that defies everything we know about comets. Every 17 minutes, like a cosmic metronome, its tail erupts in a precise pulse of gas. Data from the Gemini South Telescope in Chile, cross-checked by observatories in Hawaii and space-based platforms, confirms the cycle. 17 minutes, accurate to within seconds, repeating for days. The comet's brightness curve shows a sawtooth pattern, rising and falling with each eruption. Spectrographs reveal surges of cyanogen and carbon monoxide, classic signs of cometary outgassing. But this isn't normal. Most comets vent gas chaotically, triggered by sunlight hitting fresh ice or surface cracks. 3I/Atlas, however, pulses with eerie regularity, as if driven by an internal clock. Observers at the VLT track the plume's direction, noting that each burst aligns subtly with the comet's velocity vector. Harvard's photometry logs show microaccelerations matching the timing of these pulses, feeding directly into updated trajectory models. The implications are unsettling. 3I/Atlas isn't drifting passively through space. It's steering. Each pulse acts like a tiny thruster, nudging the comet's path by measurable amounts. For planetary defense analysts, this means every eruption could shift the margin of safety. The next pulses, already plotted on global telescope schedules, are watched with bated breath. Is this clockwork behavior a natural phenomenon or something stranger? The question has sparked late-night debates from Cambridge to Pasadena. No known comet in our solar system behaves this way. The 17-minute cycle has become the focal point of speculation. Could it be a resonance from an unknown structure within the comet, or does it hint at something more profound? As the countdown to Mars continues, 3I/Atlas's rhythmic pulses are rewriting the rules of comet science. What do you think? Could this comet be more than just a random visitor? Let's hear your theories below. Across the globe, the idea has taken hold. Could Mars, our dusty red neighbor, act as a cosmic bodyguard? A recent Pop Sky poll found 60% of respondents believe Mars could absorb a blow that might otherwise threaten Earth. The logic is compelling. Mars sits in the firing line, while Earth watches safely from 2 planets away. But the numbers tell a more complex story. At an estimated mass of 10 billion tons, 3I/Atlas carries the energy of 2 million megatons of TNT. A direct hit would shatter Martian crust, vaporize ice, and send a shockwave through its thin atmosphere. The debris plume could hurl dust and rock into interplanetary space, some with enough velocity to reach Earth. Planetary scientist Dr. Naya Tran, a familiar face on science streams, puts it vividly. Think of Mars as a cosmic bumper. It can take the hit, but the fragments could ricochet in unpredictable ways. Simulations show a halo effect, where fine dust and larger chunks drift outward for years, potentially crossing Earth's orbit. The risk to our planet is low, but not zero. Social media buzzes with what-ifs. Some call Mars a sacrificial hero. Others fear a chain reaction. Could an impact alter Mars's orbit or destabilize the solar system? Experts dismiss those concerns. Mars is too massive, and the energy, while immense, is a blip on a planetary scale. Still, the psychological impact is undeniable. For the first time, humanity is watching a planetary defense drama unfold in real time, with Mars in the spotlight. What's your take? Could Mars shield us, or would the fallout reach farther than we expect? Drop your thoughts below and subscribe for more. In control rooms at NASA and Harvard, a single diagram holds the key to 3I/Atlas's fate. The Monte Carlo Ensemble, a fan-shaped spray of possible trajectories. Each line represents a simulated path, with the best fit threading safely through space at 1.95 million kilometers from Mars. But the fan's edges, pale, wispy lines, represent the sliver of risk that keeps analysts awake. The outermost trajectories brush within 50,000 kilometers of Mars, closer than Deimos. To the untrained eye, the difference seems trivial, but in orbital mechanics, it's a chasm. Every new observation, sharper images from JWST, precise measurements from Hubble, tightens the fan. The main body of solutions, the 1 sigma zone, rules out impact, but the 3 sigma outliers, however unlikely, skirt Mars's gravitational reach. These faint lines drive contingency plans, not the reassuring bulk of the curve. Orbital analysts speak in probabilities and sigma zones, knowing that a 1 in 10 million chance, multiplied by the stakes of a planetary impact, demands action. The fan is a living document, shrinking with each data point, but never fully closing the door on disaster. As of September 17th, 2025, the fan's edges are tightening, with most scenarios clearing Mars, but the most cautious analysts refuse to look away until every outlier is erased. The margin of error, once solar system wide, now fits within a pixel on a screen. That pixel holds the world's attention, a silent countdown to certainty, or the unthinkable. What would you do if you were in the control room watching the fan narrow? Share your thoughts below. Inside NASA's Planetary Defense Coordination Office, PDCO, the arrival of 3I/Atlas triggered a rare escalation normally focused on Earthbound threats. The PDCO applied its protocols to an interstellar visitor for the first time. The trigger wasn't a single number but a convergence, a shrinking uncertainty ellipse, a non-zero risk tail within Mars's reach, and visible impact scenarios and simulations. On September 16th, when JPL's ensemble showed trajectories brushing 50,000 kilometers from Mars, the threshold was crossed, not by likelihood, but by consequences. Mars hosts a fleet of orbiters and rovers, representing billions in investment from nations like the US, Europe, China, and India. Even a remote threat demands coordination. The PDCO convened a closed-door briefing with encrypted links to ESA, Roscosmos, CNSA, and ISRO. The agenda: review trajectories, assess risks to missions, and prepare contingencies. No public statement was issued, but a classified bulletin urged mission managers to increase telemetry and prepare for asset repositioning. The Mars Reconnaissance Orbiter ramped up imaging, and the Deep Space Network shifted schedules for radar coverage. Even private players like SpaceX and Lockheed Martin weighed in, assessing risks to future Mars payloads. This wasn't a drill. The alert underscored a stark reality. Planetary defense isn't just about Earth. The machinery of global cooperation, tentative, voluntary, and untested for Mars, sprang into action. The next pulse from 3I/Atlas could mean the difference between a near miss and a planetary event. How do you think the world should prepare for threats beyond Earth? Let's discuss below. A direct hit by 3I/Atlas would be cataclysmic. With a metallic core possibly 400 meters across and a mass of 10 billion tons, the comet would unleash 2 million megatons of TNT, thousands of times greater than Earth's largest nuclear detonation. The blast would carve a crater 60 kilometers wide and 5 kilometers deep, dwarfing Arizona's Barringer crater. A shockwave would race through Mars's thin atmosphere, sending dust and superheated gas at supersonic speeds. Mars's robotic fleet, NASA's Mars Reconnaissance Orbiter, ESA's Trace Gas Orbiter, China's Tianwen-1, and the Perseverance rover would face a barrage of high-velocity debris. Orbiters could be shredded, and rovers, even thousands of kilometers away, might be destabilized by seismic ripples. The debris plume could launch rock and dust into orbit, creating a hazard for satellites for years. The loss of orbiters would cripple climate monitoring, surface mapping, and communications for future missions. For engineers who've spent decades building these machines, the prospect is gut-wrenching. A single impact could erase a generation's scientific legacy. Planetary geologists warn of broader impacts. The blast would vaporize millions of tons of rock, forming a debris ring that could shadow Mars for years, triggering a global winter. Dust storms could choke solar panels and obscure the surface, halting exploration. Atmospheric escape could thin Mars' already fragile air, reducing future habitability. Some debris might even reach Earth's orbit, though the risk remains low. The scars of such an event would rewrite Mars' geology and our plans for its future. What would the loss of Mars' missions mean for humanity's space ambitions? Share your thoughts below. The ghost of Shoemaker-Levy 9 looms large. In 1994, a comet's fragment slammed into Jupiter, carving Earth-sized scars and jolting the scientific community. That event turned planetary defense from theory to policy, but the focus remained on Earth. 3I/Atlas exposes the gap. No warning network exists for Mars, no treaty compels data sharing for other planets, and no technology can deflect a 10 billion ton object moving at 87 kilometers per second. If 3I/Atlas were aimed at Earth, evacuation would be the only option, if time allowed. For Mars, with its robotic outposts, there's no fallback. Early detection is the only defense, and even that buys limited time. Policy circles are stirring, with NASA, ESA, and CNSA drafting agreements for data exchange and coordinated responses. Private companies like SpaceX are pushing for standards to protect future Mars missions, but the gap between ambition and capability is stark. 3I/Atlas is a test of readiness, a reminder that the next threat might target a world with cities or a fledgling colony. The drive for better planetary defense is about survival. Every close call is a chance to learn, to build a future where humanity isn't caught off guard. What steps should we take to protect our cosmic neighbors? Drop your ideas below and subscribe to follow this saga. Beyond the cold numbers and orbital diagrams, the story of 3I/Atlas is igniting a global conversation that transcends science labs and mission control rooms. Across social media, science forums, and late-night talk shows, people are grappling with a question that feels both distant and deeply personal. What does it mean to watch a planet face a cosmic threat? The idea of Mars, a world we've studied, photographed, and dreamed of colonizing, standing in the crosshairs of an interstellar comet has sparked a mix of awe, fear, and hope. For some, it's a reminder of our fragility in the vastness of space. A single rogue object could upend decades of exploration. For others, it's a call to action, a chance to rally humanity's ingenuity to protect not just Earth, but all our outposts in the cosmos. Online, hashtags like #SaveMars and #CosmicShield trend as users share memes of Mars as a stoic guardian, or debate whether this event could unify nations in a shared mission. Science communicators are flooded with questions. Could we send a probe to study 3I/Atlas up close? Should we prioritize deflecting technology now? The comet's eerie 17-minute pulses have even fueled wild speculation. Some call it a cosmic signal, though scientists stress there's no evidence of anything beyond natural processes. Yet this moment is doing something profound. It's pulling people together, from amateur stargazers to policy wonks, all captivated by the same question: what if? The emotional weight is palpable. For the engineers who've poured their lives into Mars rovers, the thought of losing Perseverance or its orbiting companions is like losing a piece of their soul. For the public, it's a chance to imagine a future where humanity doesn't just survive cosmic threats, but thrives beyond them. This saga is reminding us that space exploration isn't just about data. It's about our shared dreams, our resilience, and our ability to face the unknown together. What emotions does this story stir in you? Share your hopes or fears in the comments below. The race to track 3I/Atlas has turned the world's observatories into a global symphony of vigilance, each telescope a note in a high-stakes melody. From the windswept peaks of Mauna Kea in Hawaii to the arid heights of Chile's Atacama Desert, astronomers are working around the clock to capture every photon from this interstellar intruder. The Very Large Telescope in Chile, with its 4 massive mirrors, has become a linchpin, delivering high-resolution images of the comet's nucleus and its rhythmic gas plumes. Meanwhile, the Gemini South Observatory, perched at 2,700 meters, cross-checks spectral data, confirming the cyanogen and carbon monoxide signatures that mark each 17-minute pulse. In space, the James Webb Space Telescope's infrared eyes pierce the comet's dust veil, revealing details invisible from Earth, while Hubble's veteran lenses provide unmatched clarity on its trajectory. Ground-based arrays like the Atacama Large Millimeter/Submillimeter Array, ALMA, add another layer, mapping the comet's chemical makeup to understand its outgassing behavior. This global network operates with military precision, coordinating observation schedules across time zones to ensure no pulse, no shift, no anomaly goes unseen. Amateur astronomers are joining the effort too, their backyard telescopes contributing data points to open-source platforms, creating a crowdsourced shield of observation. The stakes are clear. Every image, every spectrum, every decimal point refines the Monte Carlo fan, narrowing the gap between a near miss and disaster. The collaboration is a testament to humanity's collective resolve, but it's not without challenges. Weather disruptions, equipment limits, and the sheer unpredictability of 3I/Atlas's pulses keep teams on edge. Some observatories have canceled routine projects to focus solely on the comet, a decision that underscores the urgency. As data streams in, it's shared instantly via secure servers, fueling real-time updates to NASA and Harvard's models. This global watch is more than science. It's a shared mission to protect a planet that's captured our imagination for generations. Have you ever looked through a telescope and felt the universe's vastness? Tell us about it below and join the watch. If 3I/Atlas does strike Mars, the consequences will echo far beyond the red planet, casting a long shadow over humanity's ambitions in space. Planetary scientists are running models that paint a sobering picture. The impact's debris ring could linger for decades, a swirling gauntlet of rock and dust that threatens every orbiter and future mission. Mars's thin atmosphere, already a fragile veil, could lose significant mass as the blast's shockwave accelerates atmospheric escape, stripping away gases critical to any dream of terraforming. Subsurface ice, exposed by the crater's gaping wound, would sublimate into vapor, briefly thickening the air before it, too, drifts into the void. The resulting global dust storms could plunge Mars into a decades-long winter, with temperatures dropping by dozens of degrees and solar-powered rovers grinding to a halt. Beyond Mars, the debris cloud could seed interplanetary space with high-velocity fragments, some potentially crossing Earth's orbit years later, requiring long-term tracking to ensure our safety. The scientific loss would be staggering. Decades of data from orbiters like the Mars Reconnaissance Orbiter or China's Tianwen-1 could be wiped out, along with irreplaceable insights into Mars's climate, geology, and potential for life. For mission planners, the nightmare scenario isn't just the immediate destruction, but the ripple effects, delayed launches, canceled experiments, and a reset of humanity's Martian timeline. Yet, there's a silver lining. Such an event could galvanize investment in planetary defense, spurring new technologies to deflect or disrupt future threats. The scars on Mars would become a living laboratory, offering clues about planetary impacts and resilience. The question isn't just whether Mars can survive 3I/Atlas, but whether humanity can learn from it to build a stronger, safer presence in space. What lessons do you think we should take from this cosmic wake-up call? Drop your ideas below and subscribe to follow the story. The looming threat of 3I/Atlas has exposed a critical gap in humanity's cosmic toolkit. We're unprepared to stop an interstellar object of this magnitude. Current planetary defense strategies, honed over decades to protect Earth from near-Earth asteroids, falter when faced with a 10 billion ton comet screaming in at 87 kilometers per second. The technology to deflect such a beast, whether through kinetic impactors, gravity tractors, or nuclear disruption, remains theoretical, confined to white papers and test missions like NASA's DART, which successfully nudged a small asteroid in 2022, but was a fraction of the scale needed here. Scientists are now racing to adapt these concepts, with urgent discussions about scaling up deflection methods or deploying rapid response probes to study 3I/Atlas's composition in real time. Such a probe could reveal whether the comet's metallic core or icy mantle could be exploited to alter its path, perhaps by triggering controlled outgassing. But time is the enemy. Launch windows to intercept an object this fast are measured in weeks, not years, and no ready-to-fly mission exists. The global scientific community is rallying, with proposals circulating for a crash program to develop deflection tech, drawing parallels to the Apollo program's moonshot ambition. Private companies like SpaceX are pitching in, exploring whether their Starship platform could deliver a payload to nudge or study the comet, though the logistics are daunting. Meanwhile, the public's imagination is ablaze with ideas. Could lasers vaporize particles parts of the comet? Could we detonate a device to fragment it? Experts caution that such solutions are decades away, but the urgency of 3I/Atlas is rewriting priorities. This crisis is also spurring a rethink of international cooperation. Draft treaties are being floated to mandate data sharing and joint responses for threats to any planet, not just Earth. The stakes are clear. Mars's robotic fleet, worth billions, is at risk, and future human missions could be delayed by decades if infrastructure is lost. The science of survival isn't just about technology, it's about building a global framework to act swiftly and decisively. This moment could redefine how we protect our cosmic frontier, turning a near miss into a catalyst for innovation. What kind of tech do you think could save Mars from a future threat? Share your wildest ideas below. Mars is no stranger to cosmic violence. Its surface is a tapestry of ancient craters, each a testament to impacts that shaped its history. Planetary geologists are now poring over these scars to predict what a strike from 3I/Atlas might mean. The Hellas Basin, a 2,300-kilometer wide crater from a billions-year-old impact, dwarfs what 3I/Atlas could create, but the comet's modern strike would be a spectacle humanity has never witnessed. Unlike ancient impacts, this one would unfold under the watchful eyes of orbiters, rovers, and telescopes, offering a real-time window into planetary evolution. Scientists are modeling how a 60-kilometer wide crater would alter Mars's geology, potentially exposing subsurface ice or minerals that could rewrite our understanding of its past. The seismic ripples could trigger landslides or quakes, revealing new data about the planet's crust. But the cost would be steep. Rovers like Perseverance, searching for signs of ancient life, could be buried under dust or damaged by shockwaves, halting decades of progress. The impact would also stir Mars's atmosphere, kicking up dust storms that could mirror those seen in 2018, which silenced NASA's Opportunity rover. These storms could reveal new atmospheric dynamics, but also choke solar panels, threatening missions like China's Zhurong rover. Intriguingly, some scientists see opportunity in chaos. An impact could expose fresh material for study, offering clues about Mars's water history or potential biosignatures. Yet, the risk to current missions looms large, and the data loss could set back the search for life by years. Mars's ancient scars remind us that impacts are part of a planet's story, but in the age of human exploration, they carry new weight. The echoes of 3I/Atlas could resonate for centuries, reshaping not just Mars's surface, but our vision of its future as a second home for humanity. Have you ever wondered what Mars's scars could tell us about our own planet's past? Drop your thoughts below and join the cosmic journey. As of September 17th, 2025, 3I/Atlas remains a cosmic enigma. Its 17-minute pulses and metallic signatures defy explanation, and its trajectory keeps analysts on edge. Over 20,000 pages of orbital data and memos document the escalating alert, yet the comet's true path remains uncertain. The fate of Mars, and humanity's robotic pioneers, hangs on continued tracking and rapid advances in defense. No technology exists to deflect an interstellar object, but the story of 3I/Atlas is galvanizing action. This isn't just about one comet, it's about our place in a universe full of surprises. From Harvard's late-night number crunching to NASA's global coordination, the race is on to understand and prepare. The fan of possible futures is narrowing, but the door to the unthinkable remains ajar. Will Mars dodge this bullet, or will 3I/Atlas rewrite its history? Join the conversation, share your thoughts, theories, and hopes below. Subscribe to stay updated as humanity faces this cosmic challenge, and let's build a safer future under the stars together.